Hi, today we'll discuss the LeetCode problems number 7, reverse integer. Given a signed 32-bit integer x and return x with its digits reversed. So in this problem, the input is a 32-bit integer and here is the range. The lowest value is -2 to the 31st power, and the highest value is 2 to the 31st power minus 1. So the corresponding integer range is from So here is the actual value range specified in this problem. If reversed x causes the value to go outside the signed 32-bit integer range, then return 0. So this question basically gives you an input of an integer, and the output is an integer with all the digits reversed. For example, in the example number 1, the input is 1, 2, 3. The output is 3, 2, 1. It's backward. Let's analyze the problem with the example number 1. Here is the input x. And the value is 1, 2, 3. And here is output. The process will be like this. We'll take the digit from the least significant place and move this digit to the output. First, we will move the digit 3. And then we move the next least significant digit from the input x and append to the end of the output. This process will go on until all the digits from the x are moved to output. So after moving all the digits in the output, we have the number 321. It is the reversed number from the input x. Let's do the same process again. This time, we'll develop the formulas on how to remove the least significant digit from the input and add the same digit in the output. As you can see, the least significant digit in the input x is on the 1st digit. So to get this digit, we can use the formula x mod 10. It will give you the least significant digit in the x. So the current value for x is 1, 2, 3. And then when we mod 10, we will get 3. So we will move the digit 3 out. And then we will add the digit 3 to the least significant place in the output. So in our output, the formula to add the digit is output equal to output times 10 plus, we call this pop. Pop. So the initial value for our output is 0. And the 0 times 10 plus 3 equal to 3. After we move 3 from input to the output, then we need to shift the rest of the digit to the right. The formula for this shift is x equal to x divided by 10. So the initial value for x is 1, 2, 3. And we put pop here. Formula is x mod 10. And here is 1, 2, 3 mod 10 gives you 3. And after the shift, it will be 1, 2, 3 divided by 10, it gives you 12. So on the next iteration, we will pop out number 2 from the input x. So here, the pop will be 12 mod 10 is equal to 2. And we can shift x to the right. After the shifting, x will be 12 divided by 10 equal to 1. And for the output, before we can add 2 to the output, we need to calculate output times 10. So it will be 3 times 10 is equal to 30. Which means we will move 3 to the 10th digit. And then we add the pop, which is 2. And after the calculation, the output will be 32. So here we add 2 to the output. Now it comes to the last digit in the input x. We'll pop out the value from the least significant digit. The pop will be equal to 1 mod 10 equal to 1. After shift the x, the new value for the x will be 1 divided by 10 equal to 0. So when x equals to 0, the process will end. And then we will add the pop into the output. Before we can add 1 to the output, we will shift the output to the left. So the calculation for the shifting is 32 times 10. It gives you 320. And then we add pop to the output. The new value for the output will be 321. Okay, this is a process how to reverse the integer x. The algorithm of the process we just analyzed is simple and straightforward, but we still need to take care of one thing in the description. If reversing x causes the value to go outside of the signed 32-bit integer range, then return 0. Before we go into detail for this statement, first let's create a simple pseudocode. In our process, we will have a while loop. In the condition of our loop, we will make sure x does not equal to 0. The first step in the while loop is to pop out the least significant digit from x. So here the formula for the pop is x mod 10. The second step is to truncate the least significant digit from x. The formula is this one. Then we need to attach the pop to our answer. The formula for this step is here. These are the basic steps for our solution. Now let's discuss if the reversed x goes out the range. So here is the range. Let's give a name for these two values. Let's say this is the minimum, and the number here is the max. So our output has to be smaller or equal to the max and greater or equal to the minimum. Every time we update output, we will use output times 10 plus a pop. So we can substitute the output here with this formula. And next, we can rewrite the max in this format. The least significant digit in the max is 7. So when we use max divided by 10, it gives the number without 7. So max divided by 10 gives you the number here. And similarly, we can rewrite the minimum with this formula. The least significant digit in the minimum is -8. And the minimum divided by 10 gives the number here. And we use this number to times 10 plus -8. In case when the output goes outside of the range, there are only 4 possible values for the pop. They will be -2, -1, 1, or 2. The reason for that is because if the reverse number goes out of the range, then the digit at the highest place in the maximum or the digit in the highest place in the minimum will be the least significant digit in the output. So the digit in this place can only be 1 or 2. And similarly, the digit at this place can only be -1 or -2. As said, we can ignore the pop and also ignore the 7 from the max side and ignore the -8 from the minimum side. So our formula will be Then we can cancel out the 10. Now our output will be greater or equal to this number and is smaller or equal to this number. And in fact, our output will never be equal to this number, so we can ignore the equal. And remember, the output here is not our final answer. It's the output in the middle steps. So before we can update our output with new value, we will check if our current output value is in the range between these two numbers. So we will enhance our pseudocode with these two checks. The first check is if output is greater than which means it potentially bigger than the max value. Then we will return 0. And the next check is smaller than this value. If it's true, we'll return 0. So if our output passes these two checks, which means if we update our output at this step, it will not go outside of the range. Okay, this is all the steps in our pseudocode. Next, we'll go to the LeetCode website to do the implementation. Here's the code I have prepared in the LeetCode website. We have a while loop, and we'll continue the while loop when x is not 0. And the first step is, we will pop out the least significant digit from x. The second step will truncate the least significant digit from the x. Then we will check if there's potentially an overflow. If the overflow will happen with current value of output, we will return 0. And the next step, we will check if there is a potentially an underflow. If our current value of output is smaller than this number, then we will return 0. Once we make sure our output will not overflow or underflow, we will update the output. At the end of our solution, we will return the reversed x in the output. Okay, let's test our implementation. It passes. Let's submit the solution. The runtime of our solution is 1 millisecond and is faster than 100% of all the online submissions. Our solution has runtime (1 millisecond) and is faster than 100% of all the online submissions. And the time complexity is big O log n. I want to explain why the time complexity is the log n. It's because when we talk about the time complexity, the value here is the data size. our input is an integer, and the range of the integer is from negative 2 to the 31st power to the 2 to the 31st power minus 1. And the size of the max number, or the size of the minimum number, 32. So the time complexity in maximum is big O 32. It's equivalent to big O log 2 to the 32. And this is our input n. That's why the time complexity is big O log n. Okay, we end our discussion here. Thank you for watching.